Now we will discuss theorem number 10.5. So what is statement of theorem 10.5? According to theorem 10.5, there is one and only one circle can passes through three given non-collinear points. One and only one, that means unique circle. There is a unique circle that can passes through non-collinear points, three non-collinear points. So what is non-collinear points? The points which does not lies on a same line. So let us now consider these are the three non-collinear points A, B and C. So from these three non-collinear points, one and only one circle can pass through it. So here first point, let us now consider three non-collinear points A, B and C. A, B, C are non-collinear points. Non-collinear points, that means given 3 points does not lies on a same line. Done? Now what you have to do? We have to draw perpendicular bisector of line segment joining AB and BC. So here join this AB and BC. So for the next step we have to draw perpendicular bisector of this AB and BC. So draw the perpendicular bisector of AB and BC, which is PQ and RS respectively. So perpendicular bisector of this line segment AB is suppose PQ. All of you know how to draw the perpendicular bisector of this AB. So by using rounder and scale, you have to draw one perpendicular bisector of this AB. So this perpendicular bisector bisect this AB at right angle 90 degree. So this is our perpendicular bisector. For example, PQ. PQ is perpendicular bisector of AB and RS is the perpendicular bisector of BC. So this is perpendicular bisector of BC. It's a RS. Done? So second step, we have to draw perpendicular bisector of line segment AB and BC. So that perpendicular bisectors are PQ and RS. So this perpendicular bisector intersect each other at point O. These perpendicular bisectors intersect each other at point O. So O is the intersection point. Point O is the intersection point of perpendicular bisector of this line segment AB and BC. Done? Three non-collinear points are there. Three non-collinear points means these 3 points does not lies on a same line. We can't draw a single line which can pass through these all 3 points. Done? So these 3 points are known as non-collinear points. We have to prove that there is a unique circle. That means there is only one and one circle is there which can pass through all these 3 points. So for that we have to draw construction. This theorem 10.5 that can be proved by using this construction. Done? So we have to draw this construction. We have to write the steps of this construction, and this is how you can prove this statement of theorem 10.5. So 3 steps completed. A, B, C are 3 non-collinear points. Then we have to draw perpendicular bisector of this point line segments AB and BC, and this perpendicular bisector intersect each other at the point O. So now we are getting point O. Now here we can see that this point O lies on the perpendicular bisector PQ of AB. Point O lies on the perpendicular bisector PQ of AB. So in 7th chapter we have discussed one concept there. If we draw perpendicular bisector of line segment AB, then each and every points on this perpendicular bisector will be at equidistance from the line segment, equidistance of the end point of this line segment. If we consider one point O over here, so this point O will be at the equidistance from these end points A and B. So this distance will be equal. If we consider one point P over here, so this P will be at equidistance from this A and B. Consider one point R over here, so this R will be at equidistance from this B and this A. So every point, concept was every point on the perpendicular bisector of the line segment will be at equidistance from the end points of that line segment. जो भी लाइन सेगमेंट का हम परपेंडिकुलर बाइसेक्टर ड्रॉ कर रहे हैं, है ना, वो परपेंडिकुलर बाइसेक्टर पर आप कोई भी पॉइंट ले लो, वो पॉइंट उसकी जो लाइन सेगमेंट है उसके जो एंड पॉइंट्स हैं वहाँ पर इक्वल डिस्टेंस पर होगा. दैट इज द कॉन्सेप्ट दैट वी हैव स्टडीड इन आवर 7th चैप्टर. सो नाउ we will use this concept over here. How? So here AB is the line segment, PQ is the perpendicular bisector of this line segment AB, and this point O lies on the perpendicular bisector, and that's why we can say that this point O lies at the equidistance from this point A and this point B. So these two distances are equal, OA and OB. These two distances are equal because this point O is on the perpendicular bisector PQ of line segment AB. Same concept can be applied to the perpendicular bisector RS of the line segment BC. Here line RS is the perpendicular bisector of this line segment BC. Hence every point on this perpendicular bisector will be at equidistance from these endpoints B and C. So this point O lies on the perpendicular bisector RS of BC. Point O lies on the perpendicular bisector RS of BC, and therefore we can say that this point O will be at equidistance from these endpoints B and C. So OB will be equal to OC. So combining this both property, we can say that this OA, OB and OC are equal. OA, OB and OC, all these three distances are equal, and that means this point A, point B and point C are at the equidistance from this point O, or we can say these 3 points A, B, C are at the equidistance from the fixed point O. That is somewhat similar to the definition of circle. Now what is the definition of circle? Circle is the collection of all the points in a plane. Collection of all the points in a plane. Which type of points? Collection of all the points in a plane which are at the equidistance from the fixed point. So here these 3 points are at the equidistance from this fixed point O. So we can draw one circle which can pass through this point A, B and C. Clear? So if we consider the radius of circle equal to OA or OB or OC, we can draw one circle that can pass through this point A, B and C. Done with center O. So hence here we can draw one circle with center O with radius OA, OB and OC. But again we have to check, can we draw more than one circle which can pass through this point A, B and C? So for that we require another center. So can we get any other center from this? So to get this center we require another intersection point of these two perpendicular bisector. So here perpendicular bisector can intersect at only one point. These two perpendicular bisector can intersect at only one point. They cannot be intersect more than 2 points. So we are getting only one intersection point of this perpendicular bisector. That means we are getting a unique center for this circle. So if we are having only unique center for this circle, we are having unique circle. Done? And hence we can prove that there is one and only one. That means there is a unique circle passing through the 3 given non-collinear points in a plane. Done? So this is your theorem 10.5. From the given 3 non-collinear points in a plane, unique circle, one and only one circle can pass through it. Clear, students? So this is how you can prove your theorem number 10.5. Pause the video and note it down. Now another 2 points that you have to remember. This is about the 3 points in a plane. Then what about the 1 point and 2 points in a plane? Suppose 1 point in a plane is given, then how many circles can pass through it? Bolo. If I draw, or we can say if I put only 1 point in a circle, if I put only 1 point in a plane, then from this given point O, how many circles can pass through it? How many? Simple, infinite circles with infinite radius can pass through this given point. Done? So from the 1 point in a plane, from a 1 point in a plane, infinite many circles. So you can say infinite circles can pass through it. Infinite circles can pass through a given one point in a plane. Done? This is your first point. Second point, suppose 2 points are there. Suppose 2 points in a plane are there. Then how many circles can pass through it? Let's check. Suppose these are the 2 points, point A and point B, and check how many circles can pass through this given 2 points in a plane. How many? 1 circle, 2 circle, 3, 4, 5, or you can say infinite circles. Infinite circles. So infinite circles can pass through given 2 points in a plane. Now what about 3 points? So for 3 points in a plane, we have to check the condition for the 2 cases. First we have to check whether this given 3 points are collinear points or they are non-collinear points. Done? So if given 3 points are non-collinear points, we have proved a unique circle can pass through it. But what about if 3 points are linear points? So from the given 3 linear points, we can say that not a single circle can pass through it. These तीनों points, this given 3 points are linear points. All 3 points lies on a same line. Then how many circles can pass through it? 0. कुछ नहीं pass होगा. So from the given linear points in a plane, no circle can pass through it. And if we try to draw a circle, then we can draw one circle which passes through only 2 points in a plane. So third point may lies in the exterior of circle, or if we draw the circle like this, then third point may lies inside the circle, or point may lies on a circle. Clear? So here these are the different conditions through which the circle can pass: 1 point, 2 point, 3 points, linear or non-collinear points. Clear, students? So pause the video again and note it down.